Hi, I'm Phil Vashuran from Right Maths, and today I want to talk about solving a quadratic by completing the square. Well, this is a typical question, and it says rewrite, and I've written a quadratic there in the form x plus a squared plus b. And then it goes on to say, hence solve the equation, the quadratic equals 0. Well, the first part of the question, rewrite in the form x plus a squared, is called completing the square. So let's look at that now. Well, before we do that, let's just go back a step and make sure we know how to expand and simplify double brackets. And in particular, we want to do a perfect square. A perfect square is something which is something all squared. And in this case, let's write it out as x plus 6 times x plus 6. Then we know exactly what we're expanding out. So x times x is x squared. X times 6 is 6x. 6 times x is 6x. And 6 times 6 is 36. Now that's the expand part. Now we simplify because we can bring these two terms together. So we've got x squared plus 12x plus 36. Notice we do get the 12x term in the middle. I've seen so many students write x squared plus 36 as their answer. That's just from looking at this and saying x squared and 6 squared is x squared plus 36. Let's do the next one then. Well, it's x minus 3 times x minus 3, which is x squared minus the 3x minus another 3x plus 9. Notice a negative times a negative is a positive. We always get a positive number at the end. So it's x squared minus 6x plus 9. Now I suggest you stop the video now. I will then write in the answers and you can check yourself. So stop the video, try the next two questions, and then we'll continue. So here's the answers. Stop the video if you want more time just to check them. Otherwise, I'll carry on. Well, factorising a perfect square is just the opposite of expanding it. We've already learnt how to expand a perfect square, and that's on the left. And factorising it is just the opposite. So here we've factorised x squared plus 12x plus 6. We know that this 12 is double 6, so we can have 6 in there, and 36 is the square of 6. Now we can do the same with these. So we want half of 14 in the brackets, so we've got x plus 7 squared, and we can check 7 squared makes 49. The next one then, we need a minus this time because it's minus 18. So we want half of 18 minus 9, and that's squared, and 9 squared is 81. And the last one then, well, fairly easy, it's x plus 12, because 12 squared is 144, and double 12 is the 24. So there we have it. Now I've written in the final equation x squared plus 24x plus 145, and you can see it's one more than the previous equation. So again, I can write that as a perfect square of x plus 12, but I need to add on 1 because the 145 is one more than the 144. So I'll add on 1 at the end. Now let's just be clear where that comes from. We need 145, but from the 12 squared we get 144. So we have to do 145 minus 144, giving the 1 that we add to the end of the perfect square. Okay, so I've got 5 more examples here of completing the square. I'll do the first 2. You can then stop the video, try the next 3, and then I'll pop up the answers. Okay, well the first one I want x squared minus 10x plus 7. The minus 10 means in the brackets we need an x minus 5. And we need to square that. And then we just need to consider what we need to add or subtract to the end in order to complete the square. Well, we want the 7. So let's write that down here. But we need to take away the 5 squared that will be given from expanding these double brackets. So we minus 25, and that's minus 18. So we simply pop that on the end. Okay, the next one then, we need minus 20x, and let's write x minus 10 in the brackets, always halve the middle term. We need to square that. We want minus 3, there we go, we want that minus 3. We're going to be given 100 from the 10 squared, so we need to take away that 100, so that's minus 103. So we need to minus 103. You can always check yourself, because you can say, well, what's 10 squared? That's 100. We take away 103, so we get the minus 3 that we're looking for. Okay, stop the video now, and then when you're ready, resume and you'll see the answers. Okay, here's the solutions. We need x minus 2. We need to square it. We want 10. We have to take away the 4 from the 2 squared, so that's 6. So we need to add 6 at the end. This one is x plus 8 squared. We need a 9. We take away the 64, which is minus 55. So we need to minus 55. Last one then, x plus 3. Let's square it. We want a minus 5. We have to take away 9, so that's minus 14. Okay, so we're now in a position to solve an equation like this, a quadratic equals 0. First of all, then, we complete the square. So that's going to be x minus 4 squared, and then we need to take away the 16 and add the 3, so it's minus 13. So we've completed the square, and we'll set that equal to 0. Now it's easy from here. All we need to do is move the 13, so x minus 4 squared equals 13. Take the square root of both sides, so x minus 4 is plus or minus the square root of 13. Now do be careful. If you square root a number, you've got 2 possible answers. And then we move the 4, so x is 4 plus or minus the square root of 13. Great. Okay, so here's another one. Let's complete the square again. So x squared plus 6x minus 3, well, it equals x plus 3 all squared. Then we need to minus 12, because 9 minus 12 is minus 3. So let's solve x plus 3 squared minus 12 equals 0. Well, x plus 3 squared equals 12. So x plus 3 must be equal to plus or minus the square root of 12. So x is minus 3 plus or minus the square root of 12. And we could write that as minus 3 plus or minus 2 times the square root of 3. For the final part of this video, I want to look at solving a quadratic by completing the square when the leading coefficient, or the coefficient of x squared, is more than 1. In this case, it's 2. So the first thing I'm going to do is factorize the first 2 terms. Okay, so I'm going to put a box around them just to show you exactly what I'm doing. I'm not trying to complete the square, I'm just factorizing. So we've got 2 lots of x squared minus 3x. As I say, I have not completed the square. Okay. Now then, I'm going to complete the square for the two terms inside that bracket. Okay. So let's go down and complete the square. So just for those two terms, it's x minus 1.5 all squared, because half of 3 is 1.5. We need to take away 2.25 because 1.5 squared is 2.25. So we take away that 2.25, and we mustn't forget the minus 7 or the multiplier of 2. Okay, we can now expand the square brackets. So we've got two lots of the perfect square minus two lots of 2.25, which is minus 4.5, and then there's the minus 7. Okay, let's tidy that lot up. Two lots of the perfect square minus 11.5. Okay, so that's the completed square version of the original quadratic. Now let's go on and solve it. So let's write it out. This is the completed square version again, and we're going to set it equal to 0. Well, first of all, we move the 11.5. Then we can divide by 2. Then we can take the square root. And then my final answer is x equals 1.5 plus or minus the square root of 5.75. That's in surd form, but we could use a calculator if we wanted to put it into decimals. Okay, well, thanks for watching. If you liked it, then please do subscribe to my video channel, my YouTube channel, and also have a look at writemaths.com, which is my webpage. Thank you so much. Bye.